Good morning, everybody. Welcome to Tibbetts Physics. What is crappin'? Today, we're going to look at conservation of momentum in 2D. So this brings us back to forces on an incline, or projectile motion, or just motion in 2D. And that means we're going to have to look at components in terms of the X and Y direction. So let's go through the problem first. I've got the steps listed below, and then we'll solve it together. A red 10-kilogram ball moving at a speed of 10 meters per second crashes into a stationary 6-kilogram green ball. After the collision, the red ball bounces up at an angle of 20 degrees above the horizontal with a speed of 10 meters per second. The green ball bounces below the horizontal. What is the velocity of the green ball after the collision? So, step one, sketch a picture. This way we can figure out what has momentum, what doesn't. Draw a vector diagram of the known object after. In this case, it's the red ball. This will help us find out its x velocity and y velocity. We'll draw an LOL diagram for both our x and y components to find our v after and x and y for the second object. And then once we do that, we're going to draw a vector diagram to find our velocity after of the second object. And we need to find the angle, because velocity is magnitude and direction. So we'll also find the angle for our direction. Okay, so let's look at this step by step. A 10-kilogram ball moving at 15 meters per second. So this is before. We've got a 10-kilogram red ball that's moving at 15 meters per second. Crashes into a stationary green ball. So this is our before. After the collision, the red ball bounces above the horizontal, so it goes upwards at a speed of 10 meters per second, and it's an angle of 20 degrees. And we'll complete our vector diagram. This is our Vx, the horizontal, and our vertical is Vy. The green ball, we might as well draw it while we're at it. The green ball goes below the horizontal. Velocity we don't know, and we also don't know Vx or Vy. Oops. Vy or Vx, sorry about that. Okay. So what we want to do is we want to look at the red diagram. We know the angle and we know the hypotenuse, so from here right away we got our vector diagrams drawn. So we're going to solve for the components, that's Vx and Vy. Vx is adjacent to angle, so Vx is V cosine theta. Plug in chug, 10 meters per second, cosine of 20 degrees. Vx is 9.4 meters per second. And this is of the red ball, hence that's why we're using red. Okay, in the y direction, we got Vy. This time's y is opposite the angle, so Vy is V sine theta. Plug in chug, 10 meters per second, sine of 20 degrees, and that gives us 3.4 meters per second. Let's box these because we're going to use them pretty shortly. Okay, so we got our collision. Remember, we're looking at the x and y direction. Let's look at the x first. So we'll draw our LOL diagram. This is step 3. And we'll look in the x direction first. So before, we're saying all the momentum of the system is conserved is equal to after. Okay, so let's look at the red ball in the x direction. Is it moving? Yes. Is it moving in the x direction? Yes. So the red ball has momentum. We'll call that M1V1. The green ball, is it moving before they collide? No. So it does not have momentum. After, the red ball bounces upwards, but does it have momentum in the x direction? Yes, it does. And after, M1V1 after, M1V1. And after they collide, the green ball, it bounces downwards, but it's also moving to the right, so it also has a positive momentum. We'll call it M2V2. And again, we're looking in the x direction, so we're only analyzing the velocities and momentum in the x direction. So with our LOL diagram complete, we can now write our formula. We've got M1V1 before. We're also going to put an x there, so before in the x direction is equal to M1V1 after in the x direction. And we'll use green for now, but we'll go to a different color next, plus M2V2 after in the x direction. You know the velocity of the red ball, it's 15 meters per second in the x direction before. We know the velocity of the red ball after, it's 9.4 meters per second. So all we're solving for is V2 after in the x direction. So let's get that by itself. We'll use a neutral color. So we're going to subtract M1V1 after in the x direction. So we got M1V1 before in the x direction minus M1V1 after in the x direction all over M2. And that's equal to V2 after, V2 after, okay, let's try one more time. V2 after in the x direction. So let's just plug and chug. V2 after in the x direction is equal to 10 kilograms times, let's see here, 15 meters per second, minus 6 kilograms, still 10 kilograms of M1V1, times its speed in the x direction after is 9.4 meters per second, all over M2, which is 6 kilograms. We plug that in our calculator, we get V2AX is 9.3 meters per second. Okay, so that's part one. We solved for the conservation of momentum in the x direction. Now let's do the same thing, but in the y direction. So we got our LOLs before and after. Sorry that we still can't see the picture while drawing our LOLs, so we're going to have to do some scrolling. So we'll start with the red. The red ball is moving to the right. Does it have velocity in the y direction? No, because it's only moving to the right. So nothing for the red ball before. After, is the green ball moving at all? No. So the green ball doesn't have any momentum in the x direction. After they collide, the red ball bounces upwards. It's moving in the upward direction, so it has velocity in the y direction. And the green ball, if we look at the green picture, it's moving down, so it has negative momentum, or velocity in the negative direction. So before, we've got 0 momentum equals M1V1 after in the y direction plus M2V2 after in the y direction. We have a plus right here for now, but the math will make it negative, and that's what we want because it's going in a negative direction. We're solving for V2AY, so we'll subtract M1V1 after and divide by M2. So V2AY is equal to M1V1 after in the y direction all over M2. A little bit easier than the x direction. So let's plug and chug. V2AY is equal to 10 kilograms times the velocity in the y direction of the red object. We solve for up here v sine theta. That's 3.4 meters per second. So times 3.4 meters per second all over the mass of object 2, that's 6 kilograms. And we do that on a calculator. We get V2AY is, oh, I forgot my negative, sorry. Negative there, and a negative there, because we subtracted it over. So V2AY is negative 5.7 meters per second. And that's V2AY. Alright, almost done. So we have the velocity of object 2 in the y direction, and we have the velocity of object 2 in the x, x direction. So, let's draw a vector component of our velocity of object 2 after they collide. So we got velocity of object 2 in the x direction, and that is 9.3 meters per second. And we have velocity of object 2 in the y direction, v2 after the y direction, that's 5.7 meters per second. The vector going down helps us know that it's a negative. And we want to solve for the actual velocity of the object, the resultant velocity, and that's just v2 after. So we've got a right triangle. We're going to use right triangle trig, and right now we can use Pythagorean's theorem. A squared plus b squared equals c squared, where c is our hypotenuse. We'll get that by itself, so c is the square root of a squared plus b squared. Plug in our velocities in x and y direction. 9.3 meters per second squared. Oops. Quantity squared. Plus 5.7 meters per second. Quantity squared. Plug that in our calculator and we get a speed of 10.9 meters per second. When you take the square root, it could be positive or negative. V2 is going down, so in this case it's going to be negative 10.9 meters per second. Now we got one last thing to do. We need to find the angle, because again, velocity has both magnitude and direction. So we need to find theta. We automatically know the opposite and the adjacent. We just found those. So let's use trig. Opposite over adjacent is tangent. So tangent of theta is opposite over adjacent. And that's right in your reference table if you forget that. To solve for theta, we have to do arctan, or the inverse of tangent. So theta is tan negative 1 of opposite over adjacent. We'll plug them in right now. Opposite is 5.7 meters per second. And the adjacent, sorry, those pretzels were making me thirsty. The adjacent is 9.3 meters per second. And we plug that in a calculator. The angle is 31.5 degrees, and that's below the horizontal. So the velocity of object 2 after they collide is negative 10.9 meters per second at an angle of 31.5 degrees below the horizontal. Sounds like a tough problem, but if you break it down step by step, find the momentum in the x direction first, analyze the momentum in the y direction after, direction, not direction, and then set up your vector component of your Vx and Vy of the object after, and just solve for the resultant and the angle. Pretty straightforward, and that's it for me tonight, or this morning, or whatever I said at the beginning. And until next time, see ya.